Question 3. Which combination of units is the odd one out? First, let me point out that I dislike this question because, to me, odd one out is far too subjective. I would hope that, provided you give good enough reasoning, as long as you can convince the marker that the one you have chosen is indeed the odd one out, then hopefully they'll give you the points. So I'll show you a couple of ones that I think are odd ones out. And then, apologies, because they don't release the solutions, I have no idea what their thinking is here. So anyway, let's just get into it. So for me, the first one that sticks out immediately in a really lazy approach is C. And the reason for that is it's the only set of units that contain base SI. So you should know that the base SI units, and what do I mean by this? These are the units that basically all other units can boil down to. So from this set of units, you can make any other units in physics. So they're the fundamental units. So we've got meters, seconds, mole, amps, Kelvin, candela, which is, I don't know why, but that one, such a rogue one to put in there, but I suppose it needs to be there, and mass, kilograms for mass. So you should be able to see that this C is the only one that contains base SI units. So to me, that is a perfectly valid odd one out. I don't know whether Oxford would agree with me though. Let's try a more physicsy approach, which probably is the answer that they were looking for. So if I just get rid of this. Let's just sort of do some synthesis of each of the sets of units to see if any stick out as odd. So for A, we have coulombs volts per meter, which now I'm going to change this into quantities to see what quantity this equals. So we have charge, potential difference, and over some length, some distance, some displacement, something like this. Now it's not immediately obvious to me what this quantity would equal, so let me just do a bit more maths. So I need to sort of work out what the relationship is between Q and V and D. So I start off by saying power is potential difference times current. I then know that power is energy over time and current is charge over time. And this tells me that energy is potential difference times charge. You may have known that already, but that wasn't something that I had in the top of my head. So I've worked it out from stuff that I do know. We also know that work done, or I'll just for simplicity call that energy as well, is force times distance. So what we have here then is QV, which is E over D, and you should be able to see by this equation that E over D is a force. So we can say that for A, this is a force. Next, let's do B. So we have amps Tesla per meter. Oh, sorry, not per meter, just meter. So that would be a current times a B field times by some distance. Or let's rearrange that just to make it look more familiar. You should recognize this. A current times a B field times a distance is the force on a wire carrying current I in a B field. So this is also a force. Next, kilograms meters per second squared. That one's a pretty common one from mechanics. So we've got a mass times an acceleration, and we know that's also a force. Next, we have joule per meter. So we know that joules describes an energy, and I'm using these equal signs here very, very loosely, by the way. It's not really correct to write, some units equal some quantities, but please just forgive me for that. So we've got some energy divided by some distance, and we've already discussed that the work done formula. So work done is force times distance. So therefore, some energy over distance is also force. Remembering that work done is just energy. So all of these units so far are forces. Next, we have Coulomb meter per second, which is some sort of charge times some sort of distance divided by some time, which gives ID. And if you look at this equation, which I'll call equation 1 up here, to get this ID quantity to become a force, you need this B field here. You need to times by a B field. So this must not be a force, cannot be a force. So what we have is all of the other units are forces. This one is not a force. Therefore, one potential answer is E. So there you go. There's sort of one less lazy method is to work out the odd one out, one lazy method, and it's up to you to decide what the best one is. And apologies, you could just hear my timer. That means my sausages are ready, so it's lunchtime.